Hello, in this video tutorial I will explain you what Python sets are and briefly demonstrate what they can do for you. In short, Python sets allow the use of mathematical sets. According to Wikipedia, these are collections of well-defined and distinct objects. That means that the elements of a set have to be unique. And, as with dictionaries, there is no sort order in a set. Let's have a look. This here could be such a mathematical set, including the integers 3, 1, 2, 7 and 9. It can be defined in Python starting with curly braces and ending with curly braces, each of the elements being delimited with a comma. This is not a dictionary because each of the elements is a simple Python object and not a key-colon-value pair. Now when we have a look here, the 1 in this definition occurs 3 times. This cannot happen in a real Python set, so if we construct this set, there will be only a single 1, and only a single 2, and only a single 9, and so forth. Let's start IPython 3 to have a look here. I copy this, Ctrl C, and enter it here with Ctrl Shift V in the IPython console. And S1 is a set having a single 1, a single 2, a single 3, and so on and so forth. Let's define another set here. The set S2 here has 5 values, and in our definition the value 8 down here occurs twice. But it will only be there will only be a single 8 once you make a Python set out of it. So S2, and there are only 5 elements, so the length of S2 is 5. Now the interesting thing about sets is that we can calculate using sets. Look at this example here. Using the sets above, we can have an intersection of the two sets, that is, the elements that occur in both of the sets, S1 and S2. These are the elements 7 and element 3. We can calculate such an intersection. Intersection is S1 dot intersection with S2, and the intersection is simply a set of 3 and 7. We can also compute the union. That means all elements that are either in S1 or in S2 or in both of these sets. The union can be computed using S1 dot union with S2, and we can also calculate the difference. That means the elements that are in S1 but not in S2, 1, 2 and 9, S1 dot difference of S2, that's 1, 2 and 9. You can also use simple operands to speed up typing, so I can say S1 mathematical AND, that means the logical AND here, the bitwise AND character. S1 bitwise AND S2, that would be the intersection, 3, 7. S1 bitwise OR S2, that would be a union. S1 minus S2, that's the difference, or S2 minus S1, that's the difference as well. Noting the 8, 4 and 5 here. The more interesting thing about sets is what you can really do with them. Once in a company I worked for, I had to implement a function that essentially got 2 huge lists of query sets. Instead of making real query sets, I'll simply create lists of numbers. So this is my first list here. It has the numbers 1, 3, 5 and so on up to 100,000, not including 100,000. So roughly 50,000 elements. And let's make a second list here. This has the elements 1, 4, 7 and so on. So the length of query 1 is 50,000 and the length of query 2 is 33,333. And my task was to return a list that contained the elements that were in both of the lists I had. Now these elements in the list could be any kind of Python objects. I simply used here integers for simplicity. So the resulting value should be a list of records. A straightforward way to implement this without sets would be to say for record in query 1 if record in query 2 records.append record. So what this does is it looks at each element in query 1 and says if it is also in query 2, then append it. Now this will take a while. Why will this take so long? Because it looks at 50,000 elements in query 1, and for each element in query 1 it will look at 33,333 elements in query 2 to see if it's in there. If it's in there, it could be a bit faster, but if the record is not in query 2, this will have to look at all elements of query 2. So this takes a bit longer. My computer is 5 years old, so it might be a bit faster with your computer, but it still takes unreasonably long, definitely too long for the application we developed in the company. And that's when I first really had to use sets. Let's wait until this is done. Well, you see that there is some efficiency issue here. Still not done, and now it's finally done. This is way too long, you see. Now what I did in the company then was to use sets. So I transformed the first list into a set. This doesn't take long at all, and transformed the second list into a set. And now I wanted to have a resulting list of records. First let's look at how many records were in both lists before. 16,667. To perform the same operation as above that took so long, with sets we can do make a list out of the intersection of the two sets. So I use query set 1.intersection with query set 2 and see how long this takes. Well, that was done immediately, and the result is still the same as before. So you saw that instead of waiting a long time using sets, such basic operations as intersection, the same would be true for union and so on. Those operations are extremely fast. So I hope that this will facilitate your daily programming work and that you'll continue to enjoy coding in Python.